Hi everyone, so I wanted to talk to you about something called the combined gas law that those Khan Academy videos that I posted links for did not cover. So the combined gas law is a formula that incorporates pressure, volume, and temperature and not number of moles, which is N, or that gas law constant that the Khan Academy guy talked about called R. So it's just simply as pressure, volume, and temperature in it. This is on the back of your reference table on table T. And I want to show you how to do this because these gas laws are not on table T, so you need to know how to derive them from that combined gas law. So this is a combined gas law. It's P1V1 equals P2V2 over T1 and T2. So it's the initial pressure, the initial volume, and the initial temperature, and then you can relate that to a final pressure, volume, and temperature. Okay, so that's called the combined gas law. Then, as you saw in Khan Academy's videos, there's Boyle's law that relates pressure and volume. And so this, if we keep temperature constant and we cover it in our combined gas law, then we get this P1V1 equals P2V2. And that shows us that pressure and volume are inversely or indirectly related. Okay, so as pressure goes up, volume is going to go down, or as pressure goes down, volume is going to go up. Okay. Then we have Charles' law, which you also saw in the Khan Academy videos, and that is between volume and temperature. So that tells us if we keep pressure constant on my combined gas law, then we get V1 over T1 equals V2 over T2. So I'm holding that pressure constant now, just like also that gas FET that you guys did. And that shows us, because they're on top of each other, that shows us they're directly related. So as volume goes up, temperature will also go up, or as volume goes down, temperature will also go down, okay? One that was not on your Khan Academy videos is called Gay-Lussac's law. And this is just the last kind of relationship between pressure and temperature, holding volume constant, which you did do in the gas law FET. There just wasn't a Khan Academy video talking about it, okay? So this is where we're holding our volume constant in my combined gas law, and so I get pressure and temperature. And because they're oriented in this way in the formula, they're also directly related. So as pressure goes up, temperature also goes up. Okay, so again, to get all these, because you're not going to memorize these formulas, you are given this on table S, or I'm sorry, table T, and then you can derive the rest of these holding one of the variables constant, okay? Or you can use the entire combined gas law, which you'll use in the gas law's LTA that I post for you. I'll give you a pressure, a volume, and a temperature, and then I'll give you a second pressure and volume maybe, and you'll have to find that second temperature, and you'll have to solve for that. For instance, there's a bunch of them on there, okay? So that's where you get all of these so that you do not have to memorize those gas laws. I am going to do a little demonstration for you. If you watch those demo videos, I'm going to do one where I show you how volume and pressure relate, so Boyle's law, and then I'm also going to show you Gay-Lussac's law, pressure and temperature. Okay, so we'll look forward to that in one sec. Okay, here we have a little vacuum setup. So this is going to be our vacuum, and then we're going to attach this tube here. And then we have a syringe to adjust the pressure. So we're going to be looking at pressure and volume with a balloon, and then pressure and temperature with a little glass of water. Okay, here we go. We're going to do a balloon first, and I have an assistant come and help me. Okay, hold on to that. And we're going to, so you see the balloon size right now, and we're going to lower the pressure using this syringe. I'm going to pull back so the pressure gets lowered. And what do we think is going to happen to the volume?
The balloon will get bigger.
All right, let's see. What are you noticing?
The balloon got bigger.
Okay, so the volume goes up, the volume goes up as the pressure is going down. So those are inversely related using Boyle's law. And then if I let the pressure go, our balloon goes back to its normal size, okay? Now we're going to do an experiment with pressure and temperature. So I have a little glass of water, just regular water. I put blue dye in it so you can see it better. And we're going to lower the pressure, and if you remember, pressure and temperature are directly related, so that's also then going to lower the boiling point. So let's see what happens. So what do you think is going to happen?
The water will boil.
Oh, okay, let's see. Oh. Hopefully. Okay. I don't think it's in. Okay, let's try. This one, I'll have to shot. I don't know if it's. Oh god. You're gonna have to edit this part out. Okay. Hopefully it stays recording. Okay, let's try again. Okay. Oh, there we go. Ugh. Gets harder. Oh, there you go. What are you seeing?
It's starting to boil.
So there's some bubbles forming, which I'll show in a second once we get some more going. But because we're lowering the pressure, that's lowering the vapor pressure in there, which then is related to boiling point, so it lowers the temperature at which this water boils. Do you think it's going to be hot or cold?
Still going to be cold.
All right, let's see. Okay, so we're close to boiling here. And what happened was, you can sort of see bubbles a little bit. Since I let the pressure go, the bubbles went away. But if you feel this, it's still cold because we lowered that boiling point. Okay, so those are some of the gas laws that you studied using those Khan Academy videos, and I just wanted to give you a visual. So let me know if you have any questions, okay? Bye! Hopefully I can edit this.